Hi, and welcome to our openSAP course, Introduction to ABAP in the Cloud. My name is Quincy Anderson, and I am an instructor in the SAP Product Learning Organization. This is Unit 3, ABAP RESTful Programming Model. Before we begin, a quick recap of Unit 2, Introduction to SAP BTP ABAP. In Unit 2, we learned about SAP's vision of the intelligent enterprise and how the intelligent enterprise, along with the business technology platform, creates value for our customers. We learned what BTP ABAP environment is and how to enable it in a sub-account. We also learned about the different extension types and how BTP ABAP environment can help us create side-by-side extensions, as well as other possible scenarios we can implement using BTP ABAP environment. With that, let's get started. On this screen, we will do a brief summary of the 3 different programming models that as developers we have been able to utilize over the years. The first is classic ABAP programming. Many of you are familiar with that programming paradigm. From function modules to screens to subroutines, for example, this model has been used for years by our customers. However, times change and new needs arise, which necessitates the development of new approaches. With the emergence of mobile devices such as phones and tablets, as well as the proliferation of cloud deployments, we here at SAP realized that new paradigms were necessary. As a first step, the ABAP programming model for SAP Fiori was released with ABAP Platform Release 7.50 SPS 01. It was then that we were introduced to some new types of artifacts that we could create in our development efforts, such as Core Data Services, also known as CDS, and Business Object Processing Framework, also known as BOPF. We learned about an OData service was, and how transaction code SEGW could be used to create OData endpoints using familiar ABAP technologies such as remote enable function modules and ABAP classes. While these technologies and approaches were modern and proven, nevertheless there were some issues. One particular issue was with the brownfield scenario, where customers already had existing legacy code, which provided very detailed and granular business logic. As a result, developers, instead of needing to create new artifacts, instead they needed to reference existing artifacts in a non-disruptive manner. In addition, the continued evolution of the ABAP platform, particularly BTP ABAP environment, as well as SAP S/4HANA, necessitated continued evolution of the ABAP development paradigm. So that brings us to our current programming model, known as ABAP RESTful Programming Model, or RAP. The ABAP RESTful Programming Model was introduced with BTP ABAP Environment and also with SAP S/4HANA Cloud, starting with edition 1909. ABAP RESTful Programming Model evolves the ABAP programming model for SAP Fiori in several ways. First, SAP GUI is not necessary. All programming tasks are done using Eclipse with the ABAP Developer Tools plugin, which we first saw in Unit 2. Second, the artifacts that must be developed and the sequence and flow to develop them is simple and intuitive, leading to a smooth development process and a very fast ramp-up for developers. You will get more insight as to this in the last unit, where we do a demo implementing a side-by-side extension using the ABAP RESTful Programming Model approach. As you look on the current screen, you will notice that while both CDS and business objects do remain part of the ABAP RESTful Programming Model, the process by which business objects are developed shifts from a BOPF approach to a new type of artifact known as a behavior definition and implementation. Similarly, creation of OData logic shifts away from transaction code SEGW to the creation of a business service. As mentioned a few moments ago, the creation of these new types of artifacts are simple and easy using the Eclipse ABAP Developer Tools plugin. As we see on this screen, ABAP RESTful Programming Model has an important mission. We at SAP want everyone to use it, from internal SAP developers to external developers at customers and partners. We want it to be cloud optimized, and we follow a cloud-first strategy with ABAP RESTful Programming Model. As mentioned, we want the developer process for using it to be simple and intuitive with minimal ramp-up time. And of course, we want it to be flexible, especially being able to reference legacy code that customers want to continue using. As mentioned previously, ABAP RESTful Programming Model is based exclusively on Eclipse with the ABAP Developer Tools plugin and is based upon two techniques, namely CDS along with the ABAP language. It should be noted that the ABAP language used with ABAP RESTful Programming Model is ABAP Strict. You may remember from Unit 2 that ABAP Strict uses a subset of the ABAP language, and access to ABAP repository objects is governed by a list of released APIs. Nevertheless, even with ABAP Strict, the development process is simple and smooth. One very nice feature of ABAP RESTful Programming Model is that the technical details of the implementation are handled by runtime frameworks. As developers, we need not be concerned with their implementation and can concentrate on creating our business logic instead. Finally, on this screen, let's take a look at the specific artifacts we need to create and why. Keep in mind that in our demo in Unit 6, we will see how these artifacts are created. For now, we will get a good working definition. As always, and as we've said before, it's about the creation of value. And the value here is at the top layer entitled Service Consumption, at least from the end user's perspective. Imagine a wonderful app that we love to use. We can run it from our phone or on a tablet or using any browser that we like on any device, anytime, anywhere. That in a nutshell is the value of Fiori, our main UI strategy here at SAP. Behind that UI is where the magic happens. This is the business services provisioning layer, and it consists of several parts. First, we have a service binding and a service definition. The service binding is how that wonderful Fiori app is getting its data. In this case, the data is being supplied to the Fiori app using HTTP, and what is supplying the data is an OData service. So the service binding is where HTTP and OData are specified. Now, in the real world, you may have hundreds of different OData services. One service may retrieve customer information, and another different service may create new sales orders. Each and every one of those unique OData services will have its own service definition, which we see on the screen. Second, in the business services provisioning layer, we see business objects projection. Projection simply means to present. So imagine that you have this wonderful Fiori app. You can not only display a list of customers, but edit or create new customers on the fly. So those options must be presented to you to use. Most likely there will be buttons or links in the app that you can choose. But imagine clicking on a button and nothing happening. So the business objects projection that we see with CDS artifacts and behavior artifacts represent the presentation of the various create, edit, query, update, etc. type of logic that end users expect that the applications that they use to support. The actual implementation logic for those creates, edits, queries, updates, etc. is contained in the actual business objects and queries, those artifacts we see at the bottom under data modeling and behavior. In a nutshell, that's where you'll write the code. As we said in each previous unit, and here also, the whole is greater than the sum of its parts. Taken together, this is everything that you will develop and what it will mean for the end user. Okay, so that concludes Unit 3, ABAP RESTful Programming Model. In Unit 4, we will take a look at the extension suite. See you there.